Hi guys, I'm Jeff Eisenman with Maverick Applied Science. In our last soapbox, we talked about what causes failures. In today's soapbox, number 4, we're going to talk about FRP execution and how to prevent those failures. So let's get started. So here's where we left it last time. So you may recall we did a study of 51 FRP failures and broke it down into 5 categories. And what you'll find looking at these categories and the results is that the vast majority of these failures occurred in engineering, in fabrication, or in installation. And this accounted for about 88% of the total failures in the study. And one thing I do want to reinforce is that equally the vast majority of all of these failures could have been prevented, were preventable with proper planning and proper execution. So that's what we're going to focus on today. So just to drill down a little bit, so why do most FRP failures occur? So here's some reasons. These are some examples. Lack of understanding of the material or the product, poor judgment. There are times when we find that poor judgment creeps in when we see budgetary pressures. Bad assumptions. Basically, you want to verify the data and eliminate all the gaps. And then finally, lack of skills or expertise. And this can occur in the engineering phase or with lamination skills. There's a number of places that this can occur, so you have to be aware of that. So what I want to present is the FRP execution plan. It's a very basic plan. It's more about detail and diligence. There's no great technology here. It's a lot about effort and priorities. So we'll start here with talking about current and comprehensive specifications. Specs should be comprehensive, not performance specs. If specs are older than 5 years old, they're outdated. They're a liability to your project. Update your specs. It's probably the the lowest investment with the highest return in your project that you can do. It impacts every level of your project. And then, so moving on, we're going to talk about qualified and experienced manufacturers. You want to qualify your manufacturers on every project, possibly even audit them. We find that some manufacturers do good piping, some will do tanks very well as their primary expertise, but few do both. So know what they do, know what their capacity is, their capabilities. And finally, detailed engineering. So detailed engineering needs to be thorough. It needs to be done by qualified engineers. In the case of a piping project, it's quite likely that pipe stress analysis is merited. And then finally, diligence in QC and QA. This is in engineering. This is diligence and inspection in the shop during fabrication as well as during installation. So circling back, what causes failures in FRP? So here are some further examples. So treating FRP like steel. This could be in the engineering phase or could be in the installation phase by a contractor. Also, the temptation to choose the closest manufacturer, not necessarily the most qualified. The closest has lots of capabilities, but they're not always in production a lot of times. You know them most from field service, so make sure that you get the most qualified guy. It will definitely pay dividends. And then, again, assuming the calcs are right. Every step, every document on the project, you need to have checks and balances. So if you get calcs, make sure they're checked by qualified people. And then finally, when you know a manufacturer, you have experience with them, they've proven to do a good job in the past. You say, I trust them, but they don't need to be inspected this time. They've done a good job, so why do we need to inspect? Well, everybody has good and bad days. You don't want to let your guard down, so you need to inspect on every project. So to summarize, the solution is, don't make assumptions, don't cut corners, Select materials based on reliability, not based on cost. Uh, any cost savings you have in materials, you're likely cutting your performance, so not a good choice. Qualify your vendors. Every now and then you might need to do a shop audit. Uh, every company, every vendor goes up and down, so know where they are. And then finally, qualify your engineers, check your calcs, um, inspect throughout the project, and require documentation at every step. So basically what I'm saying here is you have to own it. You have to own an FRP project just like every other project. So be diligent, be thorough. If you don't have resources internally, look outside to get help. And as Ronald Reagan said, trust but verify in every step. If you do these things, you're going to have good projects, you're going to eliminate all them FRP issues, and you're going to feel good about it. So that's all I have for today. So we'll talk to you soon.